So today we are here to discuss the topic PERT. Myself, Shwetabh Singh, working as an assistant professor at KIET Ghaziabad. Now, what the PERT is? PERT, full form Project Evaluation and Revenue Technique. It is basically used when activity time estimates are stochastic. Means whenever there is a random probability distribution, means whenever the time active whenever the activity time cannot be deterministic in nature, so we have to go for the PERT type of technique. Okay. Now for the now when now whenever now when there is a when there is a random probability distribution, we have to go for the three type of times. Okay. So next point is this: for each activity, three value of time, optimistic, most likely, and pessimistic are estimated. Now, what the optimistic time is? It is represented by T naught. What it estimate? It basically estimate the shortest possible time required for the completion of the activity. Now, for the completion of the activity, this is the shortest possible time which a particular activity takes for the completion. Next is the most likely time. It is denoted by Tm. What it estimate? It basically estimate the time required for the completion of the activity under the normal circumstances. So if the normal circumstances prevail, this is the most likely time in which activity can be completed. Okay. Next is the pessimistic time. So how can we define the pessimistic time? It basically estimates the longest possible time required for the completion of the activity. Okay. So this is the longest time for the completion of the activity. So in the case of a PERT, where the data is randomly distributed, we have to define the three limits of time. First is the shortest limit, for which we define the optimistic time. Then the process average, here it basically denoted by the most likely time under the normal circumstances, and the upper limit is the longest possible time for the completion of the activity. Now basically PERT beta distribution is used to represent these three estimates. So beta distribution can be used in order to determine the three type of these time, namely optimistic time, most likely time, and pessimistic time. So as the PERT activities are full of uncertainties, time estimates cannot easily be converted into the cost data. So when so so uh, whenever there is a probabilistic in the nature, so the time estimation cannot be determined precisely. So the time estimate cannot be converted into the cost data. And most important point related to the PERT is that it is basically an event oriented technique. Okay. And now in what is the event, as we already discussed in the network representation. Now now what the PERT is basically an event oriented technique which follow the beta distribution type of time estimation. Now in the case of PERT, we have to calculate the expected time as well as the variance. Now what the expected time is? Expected time of an activity is determined by the this formula T naught plus 4 Tm upon Tp by 6. Now the variance, how can we define the variance? It basically measures how far a set of numbers are spread out from their average value. It means how much the data is spread from their mean value. It is basically represented by the variance, and by this formula we can calculate the variance. Now now the PERT can be defined with the help of this curve. On the y-axis, frequency is mentioned. On the x-axis, we have to monitor the time. Now the most likely time is the process average time. Okay. And the shortest possible time for the completion of an activity is represented by the optimistic time, TO, and the longest possible time for the completion of activity is pessimistic time. Okay. So how much is data spread? It can be calculated with the help of the variance. And expected time is this is the single time which can be comes out from the probabilistic time. Okay. So here we can draw the T naught, Tm, and Tp on the normal distribution type of the curve. Okay. Now what we have to do for the PERT? in the case of the PERT calculation, now we understand the PERT with the help of some example. Now if you see this, the event occurring from first to fourth having certain activity defined on the arrow. Okay, so activity A basically represented by the time 3 times 3, 6 and 9. How can we identify the 3 time estimation? So shortest time is TO, so this is TO. Longest time is TP, and mean average time is TM. Okay, so for the event 1 to 2, okay, so understand it, this is PERT. So for the PERT is an event oriented technique. What is the event? Event is 1 to 2, which is carried out by the activity A. Okay, so how we can calculate the expected time? Expected time TE1 of 1 to 2 is T naught plus 4 Tm plus Tp upon 6. Okay, T naught plus 4 into 6 plus Tp, 9 upon 6. Okay, similarly from 2 to 3 is T naught plus 4 Tm plus Tp. Okay, similarly we can calculate this value equal to 32. So this is the expected time for the completion of the event from first to the fourth. Okay, similarly TE can also be computed as summation of T naught, just add the T naught, summation of Tm, just add the Tm, multiply with the 4, summation Tp upon 6, value comes out to be 32. Now we have to go for the variance. How can we calculate the variance? Variance can be calculated by the formula Tp minus T naught upon 6. Okay, so variance for the first to second is Tp is 9, T naught is 3. So 9 minus 3 upon 6 ka square. Okay, 6 whole square. Similarly for 2 to 3 we can calculate like this. Similarly for event 3 to 4 we can calculate this value. Okay, so the variance comes out to be 5.72. So this much data spread from the process average value. So this way we can calculate the expected time for the completion of the particular event. Okay, now the second problems comes here is the following table show the job of a network along with their time estimates. Draw the project network and find the probability that the project is completed in the 14 days. Okay, so here the project is completed in 40 days will be provided to you, but here is job job and there's activity will be given. On the activity certain durations are given, means certain times are given. OT is optimistic, MT is mean time, P is the probabilistic time. Okay, so first of all we have to draw the network. How can we draw the network? So first of all we just formulate this table. So for the formula table of this activity, okay, although this is the event but we have to calculate the activity time. So event first to 1 to 2 carried out with the activity. So we just formulate the table 1, 7 and 13. Okay, expected time is formula written over here is T naught plus 4 Tm plus Tp by 6. Value comes out to be this. How we calculate the variance? Similarly with the help of this we calculate the variance. So from the activity 1 to 2 is from to 7 to 8, we just calculate each expected time and each variance time. Okay, now we have to go for the scheduling of the activity. For the scheduling of the activity we have to learn two different terminology. First is the earliest time and second is the latest time. Now the earliest time is, okay, to earliest expected time at which the activity originating from the event can be started. Okay, so this is the time at which an activity can be start. Okay, next is the latest allowable time at which activity terminating at the event can be completed. So this is known as the latest allowable time. So in the network diagram we have to calculate the value of TE and TL. Okay, now how we calculate the TE? So TE can be calculated with the help of the forward pass computation. How we calculate the TE? Now first step is begin from the start event and move towards the end point. Okay, now as we know that project has a two fixed points, starting point and end point. So we have to go from forward path, that is from the starting to the ending points. In the step number 2, put the starting event. Okay, put the starting event for TE equal to 0. Go to the next event. If there is an incoming activity for the event 2, add. Okay, calculate the TE of the previous event. Okay, you have to calculate the TE of the previous event. We can easily understand it with the help of coming example that we already taken. Okay, now I am just reading out how we calculate the TE. Note, if there are more than one incoming activities, this is very important. On the particular event, if more than one activity are coming, then which value of EL is to be taken? That value is to be taken which possess the maximum value of TE. So this point is written over here that we have to take the maximum value of the TE. Now what we have to do? We have to repeat the same procedure from the starting to the ending point. So this way we calculate the value of TE. Now TL can be computed with the backward pass computation. How can we calculate? Now for the TE, we just move from the starting to the end. In the case of TL, we have to move from the ending to the starting point. So begin from the end event and move toward the start event. Assume that the direction of the arrow is reverse. You have to assume that direction of the arrow is reverse. Okay. Now the latest time TL for the latest event is the earliest time TE of the last event. Okay. Similarly, as we calculate the TE, value of the TL can be calculated by moving from the end to the starting activity, assuming the direction of arrow may be reverse. Okay. If more than one activity coming onto the same event, then in the case of TE, we take the maximum value. For the TL, we have to take the minimum value. Okay. Just what it written over here. You have to take the minimum TL value. What the step 4 is, you have to repeat the process up to which point? Till you will not attain the starting point. Okay. So this is very important because in this example, I have to take the value of TE and the TL. Okay. Because in this question, it is also asking about the critical path also. So critical path is a new terminology. So at this phase, it can be understand only you can understand the critical path with the help of the slack. Slack means if the duration between the TL and TE are same, means TL minus TE is equal to 0. If the slack is 0, then such activity is known as the critical activities, and the path passing through such activities is known as critical path. Now we take this example. So for the better understanding of computation of TL and TE, what we have to do, we have to draw first the network. How can we draw the network? Process number 1, event 1 to 2. Okay. And how can we get the activity time? Activity time can be calculated from this point. Okay. 1 to 2, expected time is 7. Now we draw the activity 1 to 6. So activity 1 to 2, 1 to 6. Next is activity 2 to 3. So what we have to do, we have to draw the activity 2 to 3. Okay, what we get till now? 1 to 2, 1 to 6, 2 to 3. Okay. Next is 2 to 4. So what we have to draw? 2 to 4. Okay. Similarly, we can draw the each activity from the predecessor in order to get the successor, and we have to complete it till we get the end point. How can we know that which point is end point? So see it here. After the 7, activity start from 7 and ends to the 8. So 8 is the ending point. So by this we can draw this activity. We can draw this network diagram. What it show? It show the event. It show the activity. It show the duration also. Okay. Now this column, first column corresponding to TE. Okay. How we calculate the TE? By setting the first element equal to 0. So this one is TE. Okay. Now next value, how you calculate the value of next TE for the event 2? So we just add TE value of the predecessor in the activity time. So 0 plus 7 is 7. Okay. Now 7 plus 14 is 21. 21, 11 is 32. Okay. So from this you can see 5 can be attained some other path. So 5 can be reached by some other method also. Okay. Either you reach from 2 to 3 to 5, either you reach from 2 to 4 to 5. So here you can see a single event can be achieved by the 2 activity. So as we know the rule, we have to take the maximum value of TE. So what we have to do, we just take this path also. So while calculating from 2 to 5, the value of TE exists is 32. Now take this path, 2 to 4, 7 plus 5 is 12. 12 plus 7 is 19. So from this path we have 19. From this path we have 32. So the maximum value can be picked. Okay, 32. Okay. Now 32 plus 4 is 36. So 8 can be attained by this path also, from 1 to 6, 6 to 7, 7 to 8. So calculate this value also. 0 to 6 is 6. 6, 11 is 17. 17 plus 18 is 35. This way 36. This way 35. So you have to pick the maximum value of 36. Okay. Now second column correspond to the TL, that is the latest time. Okay, latest time, how we calculate the latest time? We just move from the last event to the starting point. That in the case of TE, we move from 1 to 8. In the case of TL, we just move from 8 to 1. Okay, now set this value as equal to TE of the last event. Okay, 36. Okay, now how can we move? We are just subtracting the value. Okay, so how calculate? 36 minus 4 is 32. 32 11 is 21. 21 14 is 7. So point number 2 can be achieved in a reverse manner by this path also, 5 to 4 to 2. Okay, so how we can value of this? So quite remember, this value is 32, 21 and 7. This value is 7. Now follow this path. 32 minus 7 is 25. 25 minus 5 is 20. So this way you get 20 value. This way you get 7 value, which is minimum, because for the TL we have to pick the minimum value. So minimum value is 7. Okay. Now 7 minus 7 is 0. Okay. So this one can be achieved by this, from this parameter also. Okay. For by following this path also, 8 to 7, 7 to 6, 6 to 1. So follow this path. 36 minus 18 is 18. 18 minus 11 is 7. 7 minus 6 is 1. From this path you get the value 0. From this path you get the value 1. So you have to pick the minimum value. So this value is 0. Okay. Now how can we define this critical path? Just take the value of these two, TE or TL. Just subtract it. If this is equal to 0, then this is the critical activity. So for the one, TL 0, TL 0, TE 0, TL 0, TL minus TE is 0, TL minus TE is 0, TL minus TE 0, TL minus TE 0, TL minus TE 0. So critical path is 1 to 2, 2 to 3, 3 to 5, 5 to 8. So these are the critical activities. Except all these activities, all remaining activities are non-critical activities. See, the difference is 13, difference is 1, difference is 1. So these are basically generally carry the slack value. Okay, difference in the duration. Okay, just we have to focus on that event in which duration value will be 0. That will be our critical path. So what will be my final value for the project duration? Value will be 36. Okay. Now what we have to calculate? We have to calculate the probability that a project is completed in 40 days. Okay. Now what we have to do? We have to just wrote down this value. Just Z. Well, what is the Z? Basically the Z is defined on the normal distribution curve. Z is equal to TS minus TE upon sigma. This is the schedule time. This is the expected time. This is the standard deviation or variance. Okay. Here Z is number of the standard deviation that a particular value lies above or below the mean. It defined what the Z value defined. It basically defined the standard deviation that a particular value lies above or below the mean. So how you calculate the variance? Now this is the important point. Sigma is equal to under root of sigma square. Now your path is 1 to 2, 3 to 5, 5 to 8. Now you have to take the value only for the variance of this critical path only. So take the value of sigma square from 1 to 2. So what is the value of sigma square 1 to 2 is 4. Okay. So this value is 4. Now 2 to 3 value. So what the 2 to 3 value is? 2 to 3 value is 16. Okay. So see this value 16. Now 3 to 5. Similarly Calculate the 3 to the 5 value, 4. Okay. Now 5 to 8. What the 5 to 8 is? 5 to 8 is 1. Okay. So you write 1 over here. So sigma is equal to under root of 25, that is equal to the 5. So what is the z? Z is 40 minus 36 upon 5. This is 0.8. So how you pick the value of z? You have to follow a normal distribution table. It may be provided in your exam, or it may be clubbed with the question also. So how you calculate the z equal to 0.8? So you can see it over here. Z is also mentioned that this portion, if you take this value z, then curve from the left will show the corresponding values. This is the probability for the completion. Now z equal to 0.8. 0.8. So these values are the addition value. For example, if we have to calculate the 0.8 value, so 0.00 plus 0.8 is 0.80. So 0.8 corresponding value is this 0.7881. Okay, you have to pick this value. For example, if the value comes out to be 0.85, so this is the 0.8 value. Where the 0.8? This is the 0.8, and 0.05 add into 0.8 becomes 0.85. So 0.85 value will be 0.8023. So in this manner, you can calculate the value of z. So this is the probability of your project completing in the 40 days. Okay. Okay. Thank you.